Okay, okay. Hello everyone. We are of Group 8 SBS Enterprise. Our project is about the quality control, injection, moulding, issues, and defects of the company Butech. Myself, Shravya, with my group mates, Benjamin and Suraj. So, these are the table of contents which we are going to discuss further. We are going to talk about the company overview, operational issues, and the root cause, analysis of three technology based solutions, and the recommended solutions, and the plan of action for the implementation, and ROI for selected solution, finally, references. Coming to the overview of the company. So, the Viewtech is a company which was established in the year 1988 in the Woodstock, Viewtech, in the Woodstock, Ontario. So initially, it has started with the tier 3 supplier of the automotive components. Later, it has gradually grown into the tier 1 automotive supplier with an emphasis of both exterior and the interior components. And it is also specializes in vacuum forming, glass assembling, and customer assembling and automotive interior trim. And it committed to enhance the every stage of the manufacturing development and verification. And the next is operational issues. Based on our research, we have found the two main operational issues in injection molding. The first one we thought is the manual inspection techniques, as this is one of the major concern in the Viewtech, as it has certain limitations in where the production workers uh, can't identify the dimensional inaccuracies and smaller surface defects which can be maintained by the product quality. So the next one is the various surface imperfections, which like as sink marks, short, and flash. These are the three major imperfections we can see, which we will talk individually about one. And the first one is the sink marks. Here in the picture, you can see how the sink mark looks like. It is nothing but the depression on the mounted parts surface, which were caused by the cooling related shrinkage. And the next one is the short. So this is the incomplete part which results in the material which was not fitting in the mold cavity, which it has clearly shown in the picture with the red mark identifying. And the last one is the flash. Flash is the common issue we have found. It is cast by the part's edge to develop the thin undesired protections. So the next slide is going to continue by Suraj.
Thank you, Shravya. Next part is identified root causes. As we can see in the diagram, the major cause of the contribution to the defective parts are machine is around 60%, and the injection mold around 20%, and the material is around 10, and the operator is 10. The as you can see in the fishbone diagram, the processes depend on various process variables like temperature and pressure and other parameters is mentioned in the fishbone diagram. In these process variables play a vital role in the final quality of the product. Anything difference in these process variable can result in the defective parts. During our research, uh, the defective parts causes because of the inconsistent molding techniques, because maintaining these process variables not maintaining this process variable may causes quality of the final product and lack of real-time monitoring system. Based on our root cause analysis, we are suggesting three technology based solution. The first one is real time monitoring system. The real time monitoring system will provide real time data of the injection molding machine. uh, as we mentioned in the fishbone diagram, the various parameter uh, is result in the final quality of the product. These parameter can be identified and identify in the molding machine, and this can be real time visibility on machine performance. And if anything is not in the track, or anything varying of this parameter can be controlled, and thereby we can stop the production of the defective parts. Next one is predictive analysis. Predictive analysis is nothing but use of history data and machine learning algorithm, which can use to forecast forecast the machine performance. Thereby, uh, we can uh, we can stop if anything goes wrong with the machine, or we can stop production of the defective parts. The molding process preventive adjustment reduces the defect and maximize the product quality. Then next one is automated inspection system. As we can see, Vutek is currently facing identifying in the defective parts. The company is completely rely on the manual inspection technique. Manual inspection technique is having some certain limitations, like it is very difficult to identify small surface in defects, and also any surface dimensional inaccuracies. Like automotive components need 100% dimensional accuracy for better product satisfaction. By using automated inspection system, we can easily identify this defect and guaranteeing a constant product quality. Next part is recommended solution. Benjamin will describe this recommended solution.
So, uh, from based on the three solutions we found in our research, the recommended solution is real-time monitoring. So, from the pie chart from the previous slide, it is clear that 60% of our product defects are caused by machine problems. So, in real-time monitoring, we can control and monitor the defects. Like in injection molding, we should maintain certain temperature and pressure for pressure. So by real-time monitoring, we can control and monitor these parameters. So compared to apart from real-time monitoring, the other two solutions we can only analyze the defect after the production, but this one we can find find the problem at the root itself. While the production is going on, we can find if anything goes wrong, the system alarm will goes on, and we can rectify the problem and continue the production. So this helps in producing defective products. So the devices which we recommend for real-time monitoring is IoT devices. The IoT stands for Internet of Things, and the two IoT devices we recommend are uh, Amazon Web Service IoT Core and Microsoft Azure IoT. So the plan of action for implementing real-time monitoring system at UTech. So in phase one, the scheduling and preparation of these techniques. So it takes around 2 weeks for the scheduling and preparation. In phase two, configuration and setting up of this is a real-time monitoring system in Wootek. So it takes around 4 weeks, and the phase three is validation and trial run of the system. So It takes around 6 weeks, and the final stage is like implementing this technique in Woodtuck and for the future production of parts. And the next stage is the return of investment in real-time monitoring system. So by implementing a real-time monitoring system, Woodtech it it helps Woodtech to reduce product defect rate and increase the overall efficiency of the production. It also helps the customers to get quality products, and Woodtech can save money in recycling defective products. Overall, it increases overall the implementation of real-time monitoring in Woodtech increase the offer a high return of investment for the company and increase the competition with the other automotive industry. And these are the references for our project. And thank you.
Thank you.